Hey everyone, so it's Thursday, and I think what makes the most sense to do is to just sort of pick up where we left off in our video from Tuesday. If you have any questions that have been coming up as you've gone through some of this material, please send them my way. We're going to do a sort of Q&A series on our discussion board after this video is released also, where I can hopefully address some of the questions that you had that you shared the week going into this. As you know, tried to get as many of those questions answered as possible through the course of these videos and planning this lesson. But I think there were some that came up that, while they were very interesting questions, just really didn't quite fit. And so we'll answer those questions separately, and then hopefully all the context that we've got in these past couple of videos is relevant and helpful for further understanding some of those responses. But certainly, if other questions have come up as we've gone through this, send them over. You can either shoot me an email or use that Q&A discussion board that we have built into our Canvas page. So the place we left off was thinking about what does a balanced and appropriate diet look like for a person, specifically thinking about calories. So again, those are our units of energy that we find in food. And when we're talking about food, we're referring to the kilocalorie. And so a balanced diet doesn't just mean calories either. I mean, we also have things like vitamins and minerals to think of, which, as we talked about last time, function as cofactors for the metabolic reactions throughout the body and are utilized in many of the anatomical tissues in our bodies. Like, for example, we talked about calcium and phosphorus being used in very large amounts for skeletal formation, and we'll talk about a few other molecules that are relevant for sort of structural things as well. So let's look at this definition for a balanced diet. So this is one sort of definition, and this is what the American government has to say about what makes an appropriate and balanced diet. And this can be found on the CDC website. So they say that a healthy diet should include or should emphasize fruits, vegetables, whole grains, and fat-free or low-fat milk and milk products, so dairy. Includes lean meats, poultry, fish, beans, eggs, and nuts, so just meat that is mostly muscle tissue without a lot of fat on it. And this diet is also low in saturated fats, trans fats, cholesterol, sodium, and added sugars. And in addition, meets your calorie needs or stays within that. So thinking about some of the components of this, right? We're going to be talking about different types of diets today, and we'll sort of address specifically that meat and dairy component. And you may already be sort of having some thoughts about that, given our last discussion about essential amino acids, and considering that getting a complete protein source is important, but that complete proteins can be created for us by combining two or more incomplete protein sources to get everything we need. So in terms of macronutrient composition, and that's really what we're talking about when we say, like, how do we construct a balanced diet? Because we can look at all of these ingredients separately, right? Like, we can say, like, okay, you need a lot of fruits, vegetables, blah, 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 all of these things. But what does that actually translate to? So some of you have asked, like, what is the, how much, is there a quantity of fruits and vegetables or grains or protein that I should be having in a day? And that's kind of tough to answer. We would want different amounts of these things depending on what their constituent nutritional profile looks like. So for example, if you are, following sort of the guidelines for this, then these guidelines also specify sort of where our calorie sources should come from. And so they say for like a balanced diet, 50 to 60% of your daily total calories should come from carbohydrates. And more specifically, they should be coming from complex carbohydrates. So you may have heard these terms before: simple carbohydrates and complex carbohydrates. And so complex carbohydrates are the ones that they say are like good for you. But the reason for that is because what makes a simple carbohydrate is high glucose content. So this means that if we think back to cellular respiration, remember that the first step of cellular respiration is glycolysis, which is the breaking down of glucose. So if the carbohydrates you're consuming have a high glucose concentration and content as their primary carbohydrate, then what you wind up with is a food that is able to be digested very quickly and that causes a fast release of energy. This is in contrast to a complex carbohydrate, which contains different types of carbohydrates, so different types of sugars, different oses, right? So remember, whenever we see ose at the end of the name of a molecule, we're talking about a sugar. So different molecules aside from glucose, meaning that they need to be modified, they need to be processed into glucose before they can enter the process of glycolysis. And so this process here of converting these saccharides, these carbohydrates into glucose so that they can be processed into ATP energy through cellular respiration takes time, and it takes a little bit of input of energy also to break down and sort of shift around that molecular structure. And so a complex carbohydrate, therefore, is going to have a much longer timeline for digestion because more steps need to occur to get to the point where we can break it down into ATP ultimately, because we need to get it to glucose first, then get it to ATP, versus a simple carbohydrate, which is already glucose and therefore can just immediately be broken down into energy. This is why if you consume really sugary stuff, so like candies and cakes and cookies and all the really tasty stuff that we love, this is why if you eat those, you get like a quick burst of energy. You might feel more alert. And this is why, like they say, kids get hyperactive when they have sugar, even though that's largely a myth. But what isn't a myth is that these do give you a quick increase of energy. And so certainly carbohydrates are not our only macronutrient. We also have protein and fats. And so how much of that should you be having? Well, for protein, 12 to 20% of your daily total calories should be protein. And we've talked about complete versus incomplete proteins. If you're eating a variety of sources of protein, like say you choose to have a vegetarian diet, which we'll talk about soon, or even a vegan diet, which we'll also talk about. And so you're not consuming complete sources of protein, like such as an animal source, like dairy, eggs, or meat. If you are choosing to consume plant-based proteins, if you're eating a diverse variety of foods, you're not just eating like a block of tofu and like, I don't know, rice every single, although actually that would be a complete protein source. But as long as you're having sort of like a natural variety in your diet, you're eating a lot of different types of things, you're really not at risk of being deficient in a type of amino acid. It's easier than you think to create a complete protein from several different incomplete protein sources. And so with fats, about 30% of your daily kilocalories should come from fats. And so that sounds like maybe a little bit more than you'd think, considering that, people are always talking about like, oh, like you shouldn't, cook, you shouldn't eat fried foods, right? Because they're really fatty and oily, and you shouldn't eat things with a lot of butter. And, we hear a lot of shouldn'ts like that. But remember, fats are an important part of the diet because they provide us with essential fatty acids that we disassemble within the body through the process of digestion to use those parts to assemble important structures in the body. And so this translates to roughly 50 to 80 grams of fat per day in the diet. And so things you want to avoid there are three types of fats. So there's saturated, unsaturated, and trans fats. And so what you want to avoid are the saturated and the trans fats. Those are the ones that are not super good for you. So, so what these refer to when they say saturated or unsaturated, what they're referring to is the number of hydrogens on the molecule. That's really all it is. The number of hydrogens on the lipid molecule is what makes a fat molecule either saturated or unsaturated. But that really makes a difference in the way that we process these molecules in the body. For example, the saturated fats are going to require a much different process to go through. And so we wind up with an increase in certain types of cholesterol that are not good for the body. So not all cholesterols are damaging for the body. In fact, there are two types of cholesterol. So we have HDL and LDL types of cholesterol. And these terms may sound sort of peripherally familiar to you also. But so the full name of HDL and LDL are high density lipoprotein and low density lipoprotein respectively. And so these refer to the molecular structure of these cholesterol molecules. And cholesterols are, sort of waxy, they're hydrophobic, so water repelling, and they are similar to fats in some ways in their molecular structure. And so the ones that we don't want to have are LDL cholesterols. These are our low density lipoprotein cholesterols. And the levels of those increase when we consume things like saturated and trans fats. And so I said what saturated and unsaturated fats were molecularly. Trans fats actually just refers to the difference in orientation of the fat molecule, which doesn't sound like it would make a difference, but it actually does. Molecules are very, very specific, and even small changes and differences in the positioning of their constituent atoms and slight differences in their conformations can make a really big difference, similar to proteins. And so anyway, we don't want a lot of these LDL cholesterols. These are the ones that remember I said they're really waxy molecules, so they're kind of sticky too, and so they can stick to blood vessels, particularly arteries. And so these are the ones that you hear about, like clogging people's arteries, which can restrict blood flow, particularly around the heart, where this is especially dangerous. And this is one of the things that can cause heart attacks or worse in some cases. And so HDL, high density lipoprotein cholesterols, are the ones that you want to have in your body. And you want to have high levels of those because they help remove low density lipoprotein cholesterols from the blood. And so they help sort of keep everything clean and efficient as it's moving throughout the body. Okay, so I promised I'd talk to you a little bit about types of diets, and this was a big, or let me rephrase that. This was a really common, type of question that I got from you guys, which I thought was really interesting, that you guys were so curious about, but it makes sense. This is really relevant right now. So I'm just thinking about different ways that people eat. So there is an omnivorous diet, which is probably what most people in the US have for their dietary structure. So this means you eat a little of everything. You eat meat, you eat animal products, you eat fruits, you eat vegetables, you eat grains, you eat seafood probably, unless you have an allergy, don't do that. But an omnivore is someone who's going to eat everything. This word omni has a root word meaning all or everything. And then this root word vor in here also means like to eat. And so other types of diets that are really common, and certainly there are many variations on these, but we're just going to touch on a couple of more popular ones right now. So there's vegetarian diets, which you're probably familiar with. This is somebody who doesn't eat any animal meat, so they don't eat fish, poultry, pork, or beef, but they generally will eat both eggs and dairy, but vegetables and grains are going to be the primary source of their diet. But a vegetarian will eat things like eggs and dairy and honey in addition to that. Somebody who is vegan, however, this is where it gets a little bit different, and so where we may not know as much about. So a vegan is somebody who is not going to consume any animal products at all. So this includes meat, eggs, dairy, certainly. So no cheese, no eggs, no yogurt, no milk, nothing. Certainly no animal meat. But also generally a vegan diet excludes things like honey because it's a byproduct from bees. So it's made by animals, insects. And so many vegans generally don't feel comfortable consuming honey for that reason. There's also some questionable ethics in terms of animal rights when we think about how honey is harvested commercially. Sometimes in these factory honey production systems, smoke is used to get the bees to leave the hive so the honey can be harvested, and this causes quite a lot of stress on the bees, and so sometimes they don't survive, and certainly we want to be taking really good care of the bees right now. So many vegans won't consume honey for that reason. A vegan person, depending on their individual beliefs, this may extend to all areas of their life. So somebody who is vegan may not consume these things, but also might not use cosmetics or clothing that have any association with animal life. So they wouldn't wear things like wool or leather, certainly, and they may not, they wouldn't use cosmetics that were tested on animals or contained any animal byproducts. And so some vegans, this is really interesting to me, and I'm interested to know your thoughts. So some vegan people choose to not consume yeast either. So they don't eat bread, and they don't drink beer, and they don't eat other fermented foods. So things like kombucha is a different thing, but they don't eat yeast anyway. And the reasoning that I have heard that's very common for not eating yeast is because it's a eukaryote, which, if you're scratching your head a little bit, I think is appropriate because you have been in my class, certainly, and even those of you who are new to my class this term certainly should know by now that there are more than a few types of eukaryotic cells. One of them is plants, so this logic becomes a little bit confusing. Other types of diets that are common are called pescatarian diets. So this is very similar to a vegetarian diet, but generally, but generally, this person will consume fish products. So somebody who doesn't eat any poultry, red meat, pork, but will eat, in addition to the dairy and eggs, they'll eat fish and seafood products. And so something that's kind of a popular choice right now is the keto diet, which you may have heard of. Nano is very interested in telling you about the keto diet. It is a high protein and low carbohydrate diet. So in this diet, generally fewer than 20% of your daily calories will come from carbohydrates. And the remaining calories will be mostly made up of protein sources, and the remainder will be made up of fat. So it's almost like an inverse of this. So it's almost like if you switched the recommendation for carbohydrates and protein. And so this is a popular diet because it is thought to be beneficial in weight loss, specifically a large amount of fat loss in a short period of time. So, I mean, it's easy to see why this would be appealing to a lot of people. Now, the issue is that this particular diet is sort of ripe with pseudoscience, right? They make a lot of claims about this particular diet that biologically really don't track. It really doesn't make a lot of sense. And so one of the claims that they make is that having a high protein diet that is low in carbohydrates, and so in addition to being low in carbohydrates, they would generally not have things like processed sugars. They say one of the benefits is that you can retrain your body to burn fat as its immediate energy source instead of the glucose coming in. So it sounds nice. It sounds good to say, oh, sure, I'll just train my body to do something differently. But that's not really how it works. And it doesn't work that way because we have evolved to create ATP in a very specific and elegant way. And it's not as simple as just saying, I will just tell my body to do something different. It would be very, very nice if we could power ourselves exclusively off of our fat reserves. There is some evidence that you can do this for a short period of time, but the downside is that a high protein diet, in order to reach the amount of protein that is recommended for following this diet, it generally involves a large consumption of meat products. And what I'm realizing just now that I didn't tell you is that the difference between sources for saturated versus unsaturated fats is that a good rule of thumb is that you will find almost exclusively saturated fats within animal products. So things like dairy, meat, eggs are going to contain saturated fats. If you're looking for a diet high in unsaturated fats, things that are good for you, that can contribute to high levels of these HDL cholesterols, then you want to be consuming a lot of plant fat sources. So plants that are really, really high in fat. So things like avocados are really great for you. Nuts are really good for you in that way. Plants contain no saturated fats. But if you're eating a keto diet, you have a high protein level that you're getting from a lot of intake of animal fats, of animal protein sources. Those animal protein sources also come with animal fats. And so you're also consuming large amounts of saturated fats. Saturated fats ultimately can get converted to LDL cholesterols in the body, which can contribute to high elevated blood cholesterol levels and obstruction, potentially, if this goes on for a long time. High cholesterol levels of that kind can contribute to obstruction of the blood vessels, and you could wind up being in really, really poor health as a result. There is, however, a good amount of evidence to suggest that this particular diet, the keto diet, is particularly good for people with epilepsy, certain types of epilepsy. Now, which types and why exactly that is helpful, I'm not 100% sure. That's something I'd be happy to look into and answer specific questions about if that's something anybody's interested in. But the keto diet has been shown to be helpful for managing the seizures of people with certain types of epilepsy. And it's also useful for some type 1 diabetics who have trouble managing their blood glucose levels. Now, a type 1 diabetic, as you may remember from a couple of videos ago, is somebody whose pancreatic islet cells are no longer functioning properly and are either producing insufficient amounts of or just not producing insulin. And so if they're not producing insulin, then the blood glucose levels can be raised quite high. So if you have this condition, you really want to limit the amount of carbohydrates in general that you eat, because eventually those will be converted to glucose, which ultimately gets converted into energy. But you want to have instead a diet that's really high in protein, because what I haven't told you about proteins already is that some protein will get converted into glucose eventually. Much of it is used for other stuff, but you do get some glucose and therefore some energy from protein sources. It just takes a lot longer to get there. And some of that protein that you're taking in is being used for other stuff. So this is why we also need to eat carbohydrates. Now, there's also stuff like these crazy fringe diets. There's also the paleo diet, which I didn't put on here, but certainly if you're interested, we can talk about. This is the idea that we should be eating the same way that early hominids ate, which seems ridiculous. And if you remember anything from Dr. Wheeler's presentation at the Peabody, specifically about jaw anatomy and like the cranial morphology, that doesn't really make sense anymore. We have evolved to a different point. So that doesn't really make sense to follow that diet. But there's also these wild fringe diets. So there's things like fruitarians, these are people who eat only fruit. I'm not kidding. They literally only fruit. No beans, no nuts, no broccoli. They eat only fruit. It's absolutely wild. There's breatharians who believe that they can sustain themselves on sunlight, air, and tea. These are real things, I swear to you. You can look these up. It's very weird. If you want to go down an internet rabbit hole with some of your quarantine free time. There's fungarians and fermentarians, which are kind of closely related fringe diets. So a fungarian is somebody who only eats mushrooms, and a fermentarian is somebody who only eats fermented foods. So yogurt, kombucha, kimchi, other fermented stuff, right? Like they only eat fermented foods. Most of these, there's benefits to eating fermented foods, but you should not eat only fermented foods. And yes, there's benefits to eating fungi, mushrooms, right? But you shouldn't eat only mushrooms. In general, of all of these, whatever you choose for your diet, everything should be done sort of in balance. And a goal should be ultimately to learn to listen for what your body is sort of asking for. Like, what food am I craving right now? And then how can I make a healthy choice with that? These should be kind of the goals that we look at. So this is a nutrient label, and we've all seen these before. They're on every food package in the US and probably around the world also, I imagine. But in the US, there are laws that say they need to exist and that they need to look like this. And some of you have asked, like sort of what these are and how they get this information. And so nutrient labels are created based off of this standard called the recommended daily allowances. And this is created by the FDA. And basically it says, based off of a 2,000 calorie diet for adults, how much of each macro and micronutrient that we list on these labels should this person be consuming. And so then they tell you in the sort of breakdown, they tell you like, okay, how much of these things are in the food item, and then what percent of that total daily value is there. So like in this example for this, whatever this food item is, this is just like a generic one. They're saying that per serving of this food item, there are 350 calories worth of energy. And then for fat, there's a 26% in one serving, 26% of the total calories that are recommended for this person. So that's already pretty close to the recommended like 30% in one serving of this. So ultimately you want what you eat throughout the day to equal out to 30% of your total calories. So it looks like one serving of whatever this food item is already getting you pretty close. So maybe we don't want to eat too much of that. It looks like saturated fat amount is pretty high, so we don't want a huge amount of that for that reason either. And then it gives you things like sodium, carbohydrate, fiber, sugars, and protein. So they actually tell you here that for carbohydrates, this one serving of this item only contains 7% of how many carbohydrates you should have in the day. So that would mean you'd have an extra like 43 to 53% calories of carbohydrates to work up to throughout the day. So we're already not meeting some of those guidelines right there. And then if we look at the protein though, it's actually saying there's 48% of your total daily calories in this. So there's quite a lot in there. So the way they determine, all of this is based off of two methods that are common in chemistry. And I mentioned calorimetry to you. This is something that you'll learn about in great detail about winter term in chemistry when you go on to take that, if you go on to take that next year. And so essentially calorimetry is one of the ways that they're gonna figure this out. So they incinerate it and they use thermal analysis and lots of math to figure out how much of each type of molecule is in this food source. There's also another method that they use called spectral analysis, which is pretty cool stuff. You probably won't learn about it until you take organic chemistry, if you take that. But also Dr. Frank offers a spectral analysis class. So just a quick plug for that. It's actually a pretty cool branch of chemistry because what you do is you take a sample of something and you basically run a laser through it, you run some light through it, and a graph is produced with peaks at specific points. And so these peaks represent different molecules, and each molecule has like a specific sort of signature, and it's very cool. So they use methods like this to determine how much of which type of thing is in a food item. Sometimes they don't need to do all of that. Sometimes they can just say, okay, what are the ingredients? And then essentially they'll just run some math and say, okay, out of what you've put in, now this item ultimately has, 20 grams of fat, 30 milligrams of cholesterol, 15 milligrams of sodium, and so on and so on. So, all of these are based on, I told you, a 2,000 calorie diet for an adult person. And so what does that mean though? Like people, come in all different shapes and sizes, right? People have all different types of needs. And so the tricky thing about this is that this attempts to put a one size fits all solution on top of dietary recommendations, which, to be fair, is probably, the best way to do it given the circumstances, but the diversity of people doesn't make this entirely realistic, because specific populations, and not just in the US, have additional or different recommendations that are better for them and their situation. Like for example, people who are over age 50 should be consuming additional vitamin B12 for neurological health. Pregnant people should be consuming additional folic acid because it helps with the formation of the neural tube during pregnancy. And then people of color, people who have a lot of higher levels of melanin production than white folks, generally should consume more vitamin D either through their diet or otherwise, because the melanin pigment blocks sunlight into the cells. And so this is a protective measure and protects the cells from experiencing DNA damage, but also partially blocks the synthetic pathway that produces vitamin D for the body. And so more vitamin D needs to be gathered through the diet because it's not as accessible through sunlight. So somebody else had asked about brain function and nutrition, and does the diet affect the brain? And essentially, is there such thing as brain food? And, we've heard, I think before, at least I always grew up hearing that you should eat tuna fish for your brain, right? Like people always told me when I was a little kid and in middle school and stuff, people always told me Alicia, you eat tuna because it's brain food, eat walnuts because they're brain food. And I didn't know what that meant. And I just went along with it because that's what every adult in my life told me. But then I, became a biologist, and then I learned that it's because the brain actually really relies on the intake of some of those fatty acids that we get from different foods. And fish, oily fish in particular, things like salmon and tuna, are very beneficial sources for some of those particular fatty acids that help our brains sort of function well and also help with neuron genesis. And so not only just the fat sources, but there's also, evidence to suggest that foods that are rich in anthocyanins, which generally have these are pigment molecules that generally have a blue or purple type of color to them that is visible to us, are potentially helpful for short-term memory. So sources of this would be things like blueberries and red cabbage. And I can't think of any other foods that are purple or blue right now, but purple or blue foods are going to be rich in this molecule, anthocyanins, which may be beneficial for short-term memory formation. The exact mechanism of that, I'm not totally sure of. And then the most obvious The most obvious benefit is from complex carbohydrates. So I already told you that complex carbohydrates are better for you because they get broken down into glucose more slowly and therefore can provide more sustained glucose level or glucose delivery into the body, which provides a more regular sort of production of ATP compared to foods rich in glucose or simple carbohydrates, which get immediately broken down into ATP and cause a short burst of energy. So complex carbohydrates, are going to give you that sustained energy. You require energy to power synapses in the brain. We learned about this fall term. And so sustained ATP production means sustained and regularly functioning neural connections and synapses. So how do we figure this out, right? I've given you a ton of information and you might be thinking right now, like, how do we know any of this? Like, how do I know what any of you're saying is true? The way we figured this out really is observational science. Some of this information that I've told you over these last couple of videos, we've known for hundreds of years. Some of it we have not, or we've known versions of it for hundreds of years. Things like, we started to learn the function of these nutrients and their importance and their necessity for our lives by observing sort of what happens when we don't have them. So some really, important examples through history are like the sailors who got scurvy, right? And this was, really devastating. Sailors who were out at sea for long periods of time until they found that sailors who went to sea with lots of citrus fruits wouldn't get scurvy. And they would give, some lemon or lime or grapefruit or orange to somebody afflicted with scurvy, and they would make an immediate recovery. And we didn't know at the time that it was the vitamin C, but we knew that there was something important in citrus fruits that was largely abundant in citrus fruits that was helping these people, and that more importantly was preventing the disease. And so later, we did more science and were able to isolate the relevant molecule as vitamin C. But we were able to observe the indirect effects of this hundreds of years ago. Folic acid, for example, too. You may have heard that pregnant people, and actually, I guess I just told you too, that pregnant people are recommended to take supplemental folic acid during their pregnancy. And this is because they began noticing, many decades ago, that people who were deficient in folic acid were having babies that had neural tube defects, and so they had defects of the brain, and so were not functioning very well. But an increase in folic acid in the diet or as a supplement was preventing this. Another really good example is, iodine deficiencies. If you've ever noticed that there's iodine in your salt, it's because people throughout history would develop these growths on their thyroids, and so it would appear as like this big lump on their throat. And we eventually realized that this was due to deficiency of the mineral iodine. And so adding iodine to salt was one of the first great public health initiatives related to nutrition. Also related to that was the creation of golden rice, which was one of the first major GMO crops. And this was a strain of rice that was engineered to produce extra vitamin A. And so by producing extra vitamin A, you could get this nutrient into the diets of people who needed it, because there's an eye disease called xerophthalmia that was occurring as a result of these deficiencies. And so there's all this evidence throughout history, all this historical context that has sort of led has sort of like guided the direction that we've taken the science. And so as technologies have become better and more available, we've been able to learn more about these nutrients and their importance. We've also, we've been able to model these in animals, which, maybe animal modeling is another discussion that we can have another time. But so through this, we've also been able to learn that, there are toxicities associated with fat soluble vitamins, but not water soluble vitamins. And we've also been able to connect many of these deficiencies and therefore illnesses among communities to socioeconomic status. Most of these illnesses, scurvy, neural tube defects, goiter, xerophthalmia, these don't really occur in the developing world anymore. And when they do, they are closely related to communities that are of lower socioeconomic status, and or I should say communities that are food insecure. So maybe they don't have regular access to safe and nutritious food. And so this is a real issue. And so things like golden rice and, the invention of supplements and everything have become really important towards providing relief, through humanitarian organizations, effective and quick relief, though it doesn't solve the underlying issues, to communities that are experiencing these nutrient deficiencies. And so where we're going to leave off here is, this big question, like, do I need to take vitamins? No, but also like kind of yes. Taking a multivitamin won't hurt you. If anything, it will help, unless your doctor says not to. Any other vitamins you should not take at all unless a doctor tells you to, or unless you say, hey doctor, can I take this vitamin? And they say, yes, go and take this vitamin. And the reason for this is that we know that we have fat soluble and water soluble vitamins, right? And so a fat soluble vitamin, you start going and taking doses of that in a pill. Sometimes those doses are very, very, very high, much, much, much higher than what you actually need. And so you start taking a pill for that. And if it's a fat soluble vitamin, now anything that your body can't use is getting stored in your fat. You keep taking that, and eventually you could develop a toxicity to that vitamin. Let's say it's a water soluble vitamin. Okay, well, maybe your body absorbs whatever it needs, and then the rest is excreted in urine. Okay, like vitamin C probably won't hurt you, like it's probably fine, but too much of it can cause an upset stomach. There's all kinds of things like that. And then, what about like the weird herbs and stuff that, we see sometimes? I would say definitely don't take any of those unless a doctor specifically tells you to. And the reason being for that is that these herbal supplements are generally not regulated in any way. That's the biggest thing. There are no laws saying that herbal supplements need to be regulated by the government. And so anything could be in those. It could be sawdust for all you know, and there's nothing out there to protect you from getting, scammed that way. But let's say it's not sawdust, right? Let's say you buy this herb from a reputable source that you super trust, and you know that it contains exactly what they say it contains. The other issue is that almost None of these are very well researched. And if they do have research behind them, generally it is not what we'd say robust research. And so this research may make claims that are based on small sample sizes, poorly designed control groups, a ineffectively designed experimental procedure, inconsistencies with the methodology. There can be all kinds of issues. But let's say even if, even if, it's exactly what's in the pill or the, whatever it is, it's exactly what they claim it is, and there's lots of research on it, you still should not take any of these unless a doctor specifically gives you the okay to do this. The reason for that is that many of these herbs appear innocuous because people feel, oh, it's a plant. What harm could it do? They sell it on the shelf at CVS. I don't need a prescription, right? But the issue is that if you are taking another medication, for example, if you are a person who is taking hormonal birth control, or if you are taking medication for your mental health, or even if you are taking other vitamins, or if you have if you were taking medication for your blood pressure, if you were taking any other medication, many of the popular herbs and supplements can actually interact and have what we call contraindications, which means like a negative reaction with these prescription medications. Sometimes they can bind to the medication, causing it to be ineffective. Sometimes they can diminish the effects of the medication by perhaps blocking receptors that the medication works on in the body, or potentially by blocking enzymes that the medication works on. But sometimes these herbs can amplify the effects of medication, which may or may not be harmful depending on what medication there is. So if you're thinking to yourself, or if somebody asks you like, should I take this herb that seems like it does good stuff, that I found online or that I found, on the shelf at CVS, I would tell you no. And the same goes for things like essential oils, right? They are called essential oils because they are the essence of something, not because they are essential for your body. But those can also have, some of the negative reactions that I've discussed here also. And then on top of all of that, vitamins there's some conflicting research on this, but there is some evidence to suggest that vitamins that you take as a pill form, some of them might not be as bioavailable to the body. So this means that they're not as easily able to be broken down by the body, and the nutrients within them are not as easily able to be accessed. And so in general, this isn't always true, right? Certain ones are different, but in general, eating foods that are rich in different nutrients and eating a wide variety of different foods is the best way to ensure that you're getting everything that you need. So that's where we're going to leave off. That was a lot of information. That was maybe more than the last one. So I'm going to leave you with that. And we will pick up next Tuesday with some more content. We may or may not still be exploring nutrition. We'll see kind of where we end up. We may be doing something else, perhaps a little bit of a detour into pandemic biology that might be kind of interesting. But do let me know if you have questions. I would love to hear them. I will answer some of the questions that we didn't get to in the Q&A discussion board, and I encourage you to use that to ask me some more stuff that has come up through watching this video. So until then, I will talk to you soon.